See this question now. In this case, you have 1 minus x over x raised to power 3 dx. Now, to simplify this question, the first thing is we are going to first of all simplify what we have here using laws of indices, and this will give us something like this: 1 over. What you do anytime you see this x raised to power 3 under like this, now you can separate this 1 and this minus x into different parts. So you have 1 over x raised to power 3 minus. Now what we have here is x over x raised to power 3. So we can separate it in this regard, and this is what we'll get dx. So from here we have 1 over x raised to power 3. Then from here we have minus x here 1, x here x raised to power 2. We have 1 over x raised to power 2 dx. And this can be separated in this regard again to give us x raised to power minus 3 minus x raised to power minus 2 dx. Now if we do this to give us x raised to power minus 3, you add 1 over minus 3 plus 1 minus x raised to power minus 2 plus 1 over minus 2 plus 1 minus 2 plus 1 over minus 2 plus 1 plus c, and this will give you x raised to power minus 3 plus 2 minus 3 plus 1 will give you minus 2. Then what we have here is minus 2 under minus x raised to power minus 1 over minus 1 plus c. Now separate this will give you minus, this minus should go up, so you have minus x raised to power minus 2 over 2. Then we have minus times minus is plus, so we have plus. Minus times minus is plus, we have plus x raised to power minus 1 plus c. Now this one, you don't need to write 1 again. So what you just observe here now will become, is that you have to take this down, because in laws of indices you can never have negative up. So you take this down, it will now become minus 1 over x raised to power 2 plus 1 over x, because x raised to power 1 is x plus c. But next thing is, just take note that you don't need to have negative in front, so we should have 1 over x minus 1 over x squared plus c. But this 2 here, yes, this 2 here, so that is it. So take note of it. So you can either have, like I said, you can either add c or you can add k. Any of them works out fine. So you can either have c or you have k. You understand? So in a situation where you have something like this now, let's say we have integrate 1 over x plus cos x, 1 over x plus cos x. Now take note of this point I want to give you now. Integrate whenever you integrate 1 over x, 1 over x will give you ln x. So whenever you integrate 1 over x, it will give you ln x. Ln x is in x, this one in x. So 1 over x will give you ln x. So in this place you are seeing 1 over x here now, dx. It will give you equal to 1 over x plus cos x. Now we're going to separate it to that direction, 1 over x, then we have cos x, and this will give you ln x plus plus if you integrate cos x will give you sin x, and x plus c. We have x raised to power 3 minus 2x squared minus 3x plus 1. Now we are going to break this down to give us x raised to power 3 plus 1 over 3 plus 1 minus 2x 2 plus 1 over 2 plus 1 minus 3x 1 plus 1 over 1 plus 1 plus, now this 1 you are seeing here is x raised to power 0, 1x raised to power 0, so we can say plus 1x raised to power 0 plus 1 over 0 plus 1. Now we take it step by step. Now 3 plus 1 is 4, x raised to power 4 over 4 minus 2x raised to power 3 over 3 minus 3x raised to power 2 over 2 plus 1 x raised to power 1 over 1. So we are going to say plus c. Don't forget to add c. So this will give you x raised to power 4 over 4 minus 2x raised to power 3 over 3 minus 3x raised to power 2 over 2 plus, now there's no need to write 1 again, just write x, because x raised to power 1 is 1, plus c. And this will be our final answer. So to solve this, when you just solve this, you see now it's x raised to power 3 plus 1, which is x raised to power 4 over 4. Then you have minus 2x raised to power 3 over 3. Then we have minus 3x raised to power 2 over 2 plus x plus c. So like I said in the beginning, anytime you have 1 over x, you are told to integrate 1 over x dx. It's going to give you ln x. Ln x. Ln x. That ln now, ln is in. Ln x. That's why you have x. You have this. It's going to give you ln x. Then like I said, if you are integrating sin x, if you integrate sin x will give you minus cos x. If you integrate cos x, it will give you sin x. Then if you integrate sec square x, it will give you what? Tan x. Differentiate sin x, which is x raised to power 2 plus 3x plus 2 over x plus 1 dx. Now to integrate this. Now if we want to integrate this, first things first, we'll check this equation here, or will I say, yes, this equation here. How do we go about it? Can we reduce it so that I can have this? If we can reduce it to have that, then it's fine. So let's test it. Now we have that, we have 2 here. Like I said, anytime you solve any quadratic equation, you first of all test for 2 numbers you can multiply together to give you 2. Then 2 numbers you can add together to give you 3. 2 times 1 is 2. Then 2 plus 1 is 3. So if you observe very well, we have, this will give us x squared plus x, because 1, that x now is standing for 1. So we can say 1x plus 2x plus 2 over x plus 1. So this will give us x into x plus 1 plus 2 into x plus 1 now over x plus 1. So from what we have here, we're going to pick one of the brackets. What's inside the bracket? What will inside the bracket? X plus 1. Then what do we have outside the bracket? X plus 2 over x plus 1. So x plus 1 cancel x plus 1. What do we have left? X plus 2. So we'll come back to this equation now. We now have what? X plus 2. So you see what we are integrating. What we are integrating is only x plus 2. So if what we are integrating is only x plus 2, all you just come to do here is just to write x raised to power 1 plus 1 over 1 plus 1 plus 2 x raised to power 1, 2x raised to power 0, because x raised to power 0 is 1. So 2 raised to power 0 plus 1 over 0 plus 1 plus c. And what's this? X raised to power 2 over 2 plus 2x raised to power 1 over 1 plus c. And what's this? X raised to power 2 over 2 plus 2x plus c. Very simple, right?